Okay, so we're going to begin with the same thing from last time, but this time we're going to kind of jump into the exponent part. And exponents is pretty popular, so let's do that. So this is the example C. Something like this will probably appear on your exam. Right, and for something like this, what we really have to do is basically um, first do the things in the inside. Right? Do everything in the inside of the exponent first, because it can kind of look creepy when we have to the power of -3. So my advice would be first, let's do everything that's inside. So let's do this. What is 2 divided by 4? That's the same thing as saying 1 over, not 1 over 4, 1 over 2. Right, 1 over 2. Next, let's look at a's. A to the power of -8 over a to the power of -4. What does that mean? Well, that's the same thing as saying 1 over a to the power of 8 over 1 to the power over a to the power of 4, right? Because remember, the negative fraction, or I mean, the negative exponent becomes a fraction. And we dealt with fractions before, right? This is keep, change, flip. So keep, change, and flip, right? Because we kept the first one, we changed our division into multiplication, and then we flip this around. And now we could go, which is a to the power of 4 over a to the power of 8. Good so far. Let's move on to B. B is e to the power of -3 over e to the power of 2. Right? And what that equals to is, well, same thing. B to the power of -3 is 1 over b to the power of 3 over b to the power of 2. Keep, change, flip. That becomes 1 over b to the power of 3 times, and then what is b, right? B to the power of 2 is like that as a fraction. When we flip it, it becomes 1 over b squared. What is 1 times 1? That's 1. And then what is b to the power of 3 times b to the power of 2? That is just b to the power of 5. Now we have that. So we have this portion ready. We have this portion ready. And we have this portion. And then last but not least, we have c. C to the power of 2 over c to the power of 5 is equal to, well, we just have to subtract it. 2 minus 5, so is what? And that is the same thing as 1 over c to the power of 3. We could kind of do this as well for a. So let's work with a as well. We can simplify that. What is a to the power of 4 divided by a to the power of 8? Well, we subtract the exponent, so it's a 4 minus 8. And what that gives us is a to the power of -4, which is the same thing as boom. So we have our all our sections, if you kind of want to say. So we have 1/2, we have our 1 over a to the power of 4, we have 1 over b to the power of 5, and 1 over c to the power of 3. Right? We kind of group them all together now. Right? On the top, then it's going to be a to the power of 4, b to the power of, what was it, a 5, and c to the power of 3. Notice how they're all in the denominator. So denominator, right? It's in the denominator. It's in the denominator. It's in the denominator as well. And 2 over here is also in the denominator. So that's why we get this portion, because everything was in the denominator. And last but not least, we still have this portion right here. So everything was in the denominator. That's why it's at the bottom. And now we have to do 2 to the power of negative 3. Well, 2 to the power of negative 3, right? What does that turn into? Well, it's a fraction. And this is gonna look really creepy, but it's gonna work. It's 1 over that's how it's gonna look. It's gonna look like 1 divided by a fraction to the power of 3. Keep, change, flip. Keep the first one, so it's gonna be 1. Division turns into multiplication. And then we're going to flip this fraction. We're going to flip this. When we flip it, we get right? 1 times anything is the same thing. And last but not least, we're left with just this portion to work with. And we've worked with this portion before. All we have to do is just multiply on the inside, and that's going to be 2 to the power of 3, a to the power of 4 times 3, b to the power of 5 times 3, and c to the power of 1. Oh, sorry, it's not 1, it's 3. And c to the power of 3 times 3. Because this exponent, the power rule, tells us that we could kind of multiply them inside. It will not work like that if it was separated by an operator. So I'll do an example after that. So this becomes 2 to the power of 3 is 2 times 2 is 4. 4 times 2 is 8. So it's going to be 8a to the power of 12, right? Because 4 times 3 is 12, right? And then b to the power of 15, c to the power of 9. And that is how we do it. So first, kind of do them separately, right? Kind of do them separately to work out with them, right? Put everything in your denominator, your numerator, and then once we get here, we have to kind of remember what the exponent of a negative number is, and that just means we're going to put it in a fraction form, and then we continue. So it looks pretty challenging, but with practice, you'll kind of get familiar with the rules. So something like this, a question like this will for sure be on the exam. Right. Just want to kind of say something real quick. Right. Something like this. Something like this, we could kind of just do this. 2 to the power of 3 and a to the power of 2 times 3. And that's just equal to 8a to the power of 6. However, what's not the same is this. This is not the same as just doing 2 to the power of 2 plus a to the power of 2. These are not the same. So you cannot do that. What you would do for this portion, because it's separated by an operator, so let me just write it here. So 2 plus a to the power of 2, because it has a plus sign in between them. What this really means is, we're doing 2 plus a times 2 plus a. And that gives us something like we see when we multiply binomials. And in order to do this, kind of create a box. How many terms are here? 1, 2. Right? And how many terms are here? 1, 2. Now we just multiply. What's 2 times 2? 4. 4 times a is 2a. What's 2 times a? 2a. What is a? A to the power of 2. And then we get a to the power of 2 plus 2a plus 2a plus 4. That's what we get. And at the end, we have a squared plus 4a plus 4, which is totally different from something like which is just so big difference. Oops. Big difference. These two are not the same. Okay, so let's move on to the next one. Something like that will be most definitely on the exam, so please be careful. Please remember how to do it, practice on it. Let's move on to scientific notation. So suppose we have a number 6. Right, very, very, very large number. I think that's 6,900,000,000, right? Thousands, millions. Yes. So what we have to do here is, since it's a very large number, it's going to probably be, oh, not probably, it's for sure going to be a positive exponent. So we start off here where our decimal point is, and we move 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, our scientific notation is written like this. Right? Where A has to be between 10 and 1. So notice how we have 6.9 times 10, right? 6.9, right, is in between this. It's in between it, so we know where to correct. And then last but not least, B, right? B has to be an integer, right? Or if you forgot what an integer is, it's just negative 2, negative 1, 0. It's all whole numbers that are both positive and negative. So let's count how many we did. So we did 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be 6.8 times 10 to the power of 9. And that's how we do it. Right, so let's practice here one more. Right, same thing. It's a very large number, so it's going to be positive. So we go 1, 2, 3, 4, 5, 6. We get 7.892 times 10 to the power of 1 to the power of 6. On the other hand, if it's a very, very small number like this, right, our exponent has to be negative. So 1, 2, 3, 4, 5, 6. Right? So our A still has to be so it'd be -6. So when it's a very, very small number, we have to always remember to use negative. Right? And let's kind of go reverse. if we were given something like this. Right, what this really means is we're going to start at 6.2 and move 4 spaces to the left. So we go 1, 2, 3, 4. And we get as our answer. So whenever we have a negative in the exponent, it means we're moving to the left, and that means our number has to be very, very small. As opposed to we have something like this. Right? Positive means it's a very large number, so it's 2, 3, and that's 230,000. Okay. You'll probably get like one question like this on the exam. Evaluating function. Sometimes they'll say something like this. Right. And all this really means is they're going to give you an X value and you have to plug it in. So they say, right, all this really means is for every X that I have, for every X that I have, I'm going to plug in 3. And I get 3 to the power of 2 is 9 plus 8 times 3 is 24 minus 1. And that gives me 32. And that's really just what you're supposed to do. So whenever you see evaluate or f of something, you have to plug it in. So let's do. So we do. Negative 3 to the power of 2 is 9. Right? 9 minus 3 is 6. And the absolute value is 6. We get 6. Right? Nothing crazy. It's just sometimes a lot of students get confused of the notation. And that's just basically what it means. Finding the domain of a function. All right. This is one that we have to remember the domain. So let's say we're given right? Finding the domain of a function like this, or in a fraction form, what do we know? Fractions cannot have zeros. So we have to make sure that when will this be 0? And that's our goal. Well, then we just do x plus 5. And when will x plus 5 equal 0? We could solve that. Well, we've done with this before. What's the opposite of positive 5? Minus 5. And we get x is equal to negative 5. Right? So when x is negative 5, the denominator is 0. and that is an error. That is a big no-no. So our x cannot be -5. In terms of domain, though, we go back to our drawing board. Okay. So we have all these numbers. We have all these numbers, and the only number that we cannot be, is 5. 5, we cannot be 5. Or we cannot be -5. We cannot be -5. We could be any other number but -5. So that means from -5, all of this is true, and all of that is true. But -5, we cannot be -5. So any number is from -infinity to 5, -5, but it cannot be -5. And any number or union, right? The U means union, -5 to infinity. So the only number it cannot be is -5, and this would be our domain. Okay, because when x is -5, it causes it to be 0, right? There's an error when x is equal to -5 because it causes our denominator to be 0. So x could be any number it could possibly be, right? Or it could possibly want to be except -5. And that's what it tells us right here, right? X could be any number except -5. So it could be any number from -infinity all the way till -5, but it can't be -5. And anything from -5, right? But not -5 to infinity. So all these numbers except -5. Okay, rewriting at our slope intercept form. So let's recall. Right? Or starting value. So when given something like this, we want at the end to look something like this. And how we do that, we isolate for y. So in order to get y by itself, what's the opposite of plus x? Minus x. That cancels out, and we get y is equal to 4 minus x. Or we just switched our numbers around. But that is still valid, and that's how we get into y equals mx with b form, or slope intercept. Okay. So sometimes the questions look a bit different. So something like this. I want y by myself, so let's do plus 15 on both sides. That cancels out. And we get 3x plus 15 is equal to 5y. All right, we divide by 5 on both sides, and we get 3 over 5x plus 15 over 5. Right, we could simplify, and we get and if they ask you to graph this, all we have to do is just create a table, right? X, f of x or y, and we do and so on. And we plug in our values, whatever we get something. Oh, one thing I want to say. Right, the x kind of goes right there, right next to it. Okay, so it's 3/5 x plus 3. Finding the slope, right? Remember, the slope is the change in y over the change in x. What does this really mean? Just means the subtraction. So y1 minus y2 or x1 minus x2, right? In some books, it's actually and all that really matters is that these correspond. So make sure that 1 is on top of 1, 2 is on top of 2, and this way 2 is on top of 2, and 1 is on top of 1. So let's look at an example. Right, find the slope of points. Fine. And right, so if I want this to be right, all we have to do is just do, and notice as I'm doing this one, I have to do that one as well. Okay, notice how I did that. I have to do that at the bottom. So then 10 minus 5 is 5. And then this becomes, and our slope is just 1. Okay. Um, we got to look at something like this now. Find parallel. Find parallel line of -2 comma 4. So our first goal, our first step is to rewrite 2x plus 3y is equal to 6 as y equals mx plus b. That's our first goal. Let's do that. And we get divided by 3. And we get y is equal to -2 over 3x plus 2. Now, the only thing we care about for parallel lines is that they have to be the same slope. So all we really care about is the slope. So parallel lines, So they have the same slope, but different b's or y-intercepts. So same slope, just different y-intercept. So now that we know our equation, all we care about is that, and we get to do the following. It has to cross what? It has to cross this line. It has to cross this point, so we had to use point slope formula. So what we do, that's my y, so it's going to be this becomes a plus, and we get distribute becomes -4/3. Last but not least, we have to add 4 on both sides. And we get y is equal to and then what is that? And that becomes -4 plus 12 is and that's how we do it. So first you have to kind of rewrite this, right, as y equals mx plus b, right? Which we did, but all we really care about is the slope. Once we get the slope, we use the point slope formula, plug the things we do know, and then we're able to solve for our line. So this is parallel and crosses -2, 4. And that's how you do a question like this. For perpendicular, it's the same thing, but you just have to remember you have to do the negative reciprocal. One thing real quickly, we have something like this, right? And it's perpendicular. Right? Well, what is x is equal to 3? So let's look at that graph. X is equal to 3. Well, this is my x-axis. This is my y-axis. Oops. Right? All I have to do is now do the following. Right? When x is equal to 3, I'm going to go, and my line is going to look like this. This is x. Oops. This is x is equal to 3. If I want to be perpendicular at 1, 1, it had to be that way. So it's, and boom, that's how I do it. Because it's at point 1, 1. And that's my perpendicular line. It's wherever my wherever my point's gonna be at, its y value is gonna be that line. That's gonna be perpendicular to x is equal to 3.